Good afternoon, everyone. I welcome you back to my YouTube channel, and presenting before you this tutorial is Hampio Kliman. So if you are new to the channel, don't forget to subscribe and also hit the like button, and also don't forget to share our channel to others. So in this tutorial, we will be doing integration by partial fractions. So a lot of students find this topic very difficult, but then it's one of the simplest topics, especially if you understand the concept. So integration by partial fractions is simply a relationship that is between calculus and partial fractions. And of course, I'll go there by solving the first question. So in this question, we have been taught that the integral of 3 over x plus 2 x minus 2 dx. So when you're dealing with integration by partial fractions, one thing that you must be able to understand is simply how to break everything into partial fractions. And of course, this can also be written as equal to, first thing to do is to bring out the letters to solve. Okay, so this is just the same as the integration of a over x plus 2 dx. And of course, we add and establish another letter which we can copy and write the second expression, which is x minus 2 dx. Alright, from here we can now remove the integral and just remain with whatever we have now, and that is our x plus 2 and our x, this is minus 2, and that is going to equal to a over, this is x plus 2, this is plus b over, this is x minus 2. From here we can find the common denominator, and of course the common denominator is simply x plus 2 and x minus 2. So when you reach here, what I do, I just cancel everything out and everything out here, and then I'm going to remain with 3 equal to, so if you do cross multiplication here, this is just the same as a is multiplying x minus 2 plus b multiplying x plus 2, and of course you can write your a, this is x minus 2, you say plus, this is going to be b x plus 2. And when you reach here, you need to find a number such that if you equate it to x, it can cancel either a or b. So in this case, I know that if I want to calculate b, then I must let my x equal to 2. If I let x equal to 2, I know that if I put 2 here, it will be 0, and 0 multiplied by a, my a is going to go, and I'm going to remain with b and replace my 2 where there is x plus 2, and this is going to be 3 equal to 4b. If I cancel over 4, I cancel over 4, my b is going to remain 3 over 4. Okay, and on the other side, if I let my x equal to -2. Okay, then of course I know that I will cancel this guy here because this and this will go. So of course I'm going to remain with a 3 equal to, this is going to be a minus -2 minus 2, and of course this is going to be 3 equal to a -4. So if I cancel on both sides, I'm going to remain with a equal to -3/4. Okay, so having established this, we can wrap. Let me try to create some space. Okay, so the most important thing under this topic is simply to calculate a and b, or whichever number that you have been told to calculate. Okay, so from here we can proceed. So our b is 3/4 and our a is simply -3/4. So from here you can now use this and that. So what is our a? We have been told that our a is simply 3/4. This is simply integral, so over, this is going to be x plus 2. Say plus, this is dx. Say plus, this is going to be, okay, this is for a, of course we can put our negative this side, and for b it's going to be 3/4. This is supposed to be integral of x minus 2 dx, and of course this is just the same as negative the integral of 3 over, this is going to be 4x plus 2, like that. We said dx plus, this is the integral of course this is going to be 3/4x minus 2. Okay, this is dx. Now upon reaching here, this can also be written as -3. We remove the constants outside. Of course we'll remain with the integral of 1 over, this is x plus 2. Okay, dx plus, this is just the same as 3/4 integral of 1 over, this is just the same as x minus 2 dx. Okay, so when you establish this, it becomes very simple to solve. Okay, so from here we know that integral of 1 over, so dy dx, sorry, if you integral of 1 over x is equal to ln the absolute value of x closed absolute value. So use that concept. So this is just the same as -3/4. What is the integral of x plus 2? It is simply ln the absolute value of x plus 2 closed absolute value plus 3/4. Natural log of this is just the same as ln absolute value x minus 2 plus some constant c. And of course, if you want, you can write this comes first, then it will be 3. Okay, let me try to write it with my red pen. this is going to be 3 over 4 natural log of this is x minus 2 minus 3 over 4 the natural log of this is x plus 2 plus c. And this is our final answer for the first question. Alright, so I'll try to solve C. If I solve C, then it means you'll be able to solve D and B. B is just the same as C, of course, the same concept. So we have the integral, and I'll be very quick. So this is for C. So we have the integral of this is x to the power 2 plus 1 over this is x to the power 2 plus 2x minus 3. So whenever you're given something like this, you first of all deal with the denominator. And of course, we have x to the power 2 plus 2x minus 3. This is equal to 0. So we're going to find the product, and then we find the sum. The product is simply negative 3. And the sum, of course, is simply positive 2. So with what numbers can we multiply together to get negative 3? Of course, it's negative 1 multiplied by 3, and we get negative 3. And what two numbers, if we add them, we get this is simply negative 1 plus 3, and we get 2. So of course, we see that the products are simply negative. The products are simply negative 1 and 3. These are the factors. So of course, we can replace. We have x to the power 2, say minus x plus this is going to be 3x minus 3 equal to 0. And then we do our we factor out x, and of course we'll remain with this is x minus 1, and then this is 3x minus 1, of course, and we put 0 here. We'll remain with x minus 1, and then we remain with x plus 3. So this is what we have. So C can also be written as, so this can also be written as the integral of x to the power 2 plus 1 over. So the main essence of this is simply partial fractions. That's all. Okay, so having written it like this, it becomes very simple. Okay, so let me just grab my board. Alright, so from here, this can also be written as, we write it in partial fractions. So in partial fractions, we only consider the denominator. So of course, the first one will say the denominator is x minus 1 dx plus, for the second one, the denominator is simply x plus 3. We say dx. And of course, we'll start with a, and then we end with b. Then we solve them in their individual capacities. So the way to solve them in their individual capacities, we'll remove the integral and then equate everything to a over x minus 1, say plus this is b over x plus 3. And of course, we find the common denominator like in the first place. We find the common denominator like in the first place. So we have x minus 1, we have x plus 3. So if we cross multiply, we'll get x plus 3 plus b, then x minus 1, like that. So here we have x to the power 2 plus 1 over, this is x minus 1, and this is x plus 3. So we just cancel everything that is here. Okay, so if we cancel everything out there, we are going to remain with something which will look like this. And the way to cancel out this, I know that if I put -1, then I'm going to cancel my x. Okay, +1 rather. So if I say let x equal to 1, then it means that I've cancelled out everything here. Okay, so if my x is 1, then of course I'll put my 1 here, plus 1 equal to, this is going to be x, this is going to be a, then 1 plus 3, and of course this is going to be 2, and here we're going to have a 4 inside over 4, and of course we get our a to be 1 over 2. Okay, so if I let my b be my x equal to -3, okay, let me write something here. I think this will be of help. So I can say that my a is equal to 1 over 2. Let me try to wrap this. If I put my x equal to -3, then I know that it will be very simple because I've already cancelled this part. So if my x is -3, I'll put my -3 right there, and of course this is going to be b, then -3 plus 1. So this is going to be 9 plus 1 equal to, and this is going to be -2b. Okay, so this is going to be -2b. This is going to be -2 and -2. So if we cancel out this, our b is going to be -5. Okay, so we have b equal to -5. Then I can replace everything in my equations. Okay, let me just clear my board. So my a, of course, was 1 over 2. So this is going to be integral of 1 over 2, then x minus 1. Then we say plus the integral of, this is -5 over, this is x plus 3 dx. Okay, so the first thing to do is simply to remove this. We remain with 1 over 2 integral of 1 over, this is x minus 1. We say plus, and of course we're going to get -5, the integral of, this is 1 over x plus 3 dx. From here, what is the integral of 1 over x? Remember, integral of 1 over an expression of x is just the same as ln absolute value of x. Okay, so here this is just the same as 1 over 2, the natural log of the absolute value of x minus 1 minus 5, the natural log of the absolute value of x plus 2, close absolute value plus some constant c. And this happens to be our final answer. So if you enjoyed this question, you enjoyed this tutorial, and you are able to answer all the questions, please consider subscribing and consider sharing to others. Thank you so much.